Yeah, we know that what is a resultant force. Resultant force is nothing but that single force which can replace a given set of forces, or which can do the same work done by a given set of forces acting together. So the process of finding out the resultant of any given force system is called as what? Composition of forces. So the resultant of a given force system can be done by using parallelogram law if we have only two forces acting on a body. But if we have more than two forces acting on a body, parallelogram law cannot be applied. So we have to resort to another method which is called as method of resolution. So let us study what is this method of resolution first. So resolution of forces, the definition is like this. This is the exactly opposite process of composition of forces. So in composition of forces, we combine all the given forces into one single force. So in the opposite process means if there is any force given, it has to be split into smaller forces which are called as component forces. So let us try to exactly know what is this resolution of forces first. So if you see here, I have a body or a particle O on which there is a force F acting. So due to the effect of this force F, the particle will move in this direction or the direction of the given force. But if instead of the work getting done by one single force, I can get the same work done by a set of forces here. That means I can split this given force into a number of component forces like this. So the component force, I am calling it as F1, and another component force F2. That means this force F can be split into two component forces, F1 and F2 only, or more number of component of forces like F1, F2, F3. So the process of splitting a given force into a number of component forces is called as resolution of forces. So these forces F1, F2 are called as resolved components, or they are also this process is called as resolution of forces. And we also have to specify the direction in which these component forces should be acting. So the angle made by the component force F1 with the direction of the given force F is called as theta 1. Similarly, theta 2 is the angle made by the component force F2 with the given direction F2, and F theta 3. So when a given force of magnitude F is given, we can split it into a number of component forces. In this case, the given force has been split into three component forces. But this splitting a given force into three component forces in arbitrary direction has of no much importance in mechanics. So another case here, the given force F, I am thinking of resolving it into only two component forces, making angles theta 1 and theta 2 with the direction of the given force F. But if you observe here, the given force F1 and F2 are acting in arbitrary direction. So resolving them and getting the magnitudes of F1 and F2 will be a slightly a tedious process. So even this we don't practice in mechanics. That is, resolving a given force into two component forces acting only in arbitrary direction can be done, but getting the magnitudes will be difficult. That is why we don't try to split them into component forces in arbitrary direction. Then which is the suitable method, you can see here in the next diagram here. F represents a given force acting on a particle or on a body O. Now through this point of application of the force, I am considering one horizontal line which itself I call it as x-axis, and I have another axis which is nothing but our y-axis also, which we know. Now if you see here, the direction of the given force F with the x direction should be known. So if this magnitude and direction of the given force are known, I can resolve this given force along into two component forces, one along x direction and the other one acting along y direction. So this force is, I call it as Fx, and another force in the y direction called as Fy. That means here I am thinking of resolving this given force into only two component forces, which are Fx and Fy, which are acting in standard directions, which are nothing but x direction and y direction. The component force along the x direction is called as Fx, and the component force along y direction is called as Fy. So since I know f value and theta value, it is easy to get the values of Fx and Fy. That I can do it by again some trigonometry concepts here. So what is that I am going to do? If you just see here, I'll just show you here, then come to the description. If you see here, this side also is nothing but Fy, or if I draw one more horizontal through this point here, I get another force here. So now this is also our Fx, and this is also our Fy. So my intention is to get the values of Fx and Fy, which are nothing but resolved components of the force along x and y direction. But if you observe here, there are two right angle triangles that we can see here, in which the given force is becoming the hypotenuse of the right angle triangle, and this theta is the included angle. And with respect to this triangle, Fx is nothing but the adjacent side and Fy is nothing but the opposite side. Since we know the hypotenuse as f and this angle theta, it is easy to get Fx and Fy by two simple trigonometric functions, which are nothing but Fx is equal to what? F cos theta. The reason is, if you take cos theta trigonometric function, cos theta is nothing but adjacent side by hypotenuse. So that is why, since cos theta is Fx by f, therefore Fx is f cos theta. We already know, or you will be given f value and theta value. So getting the x component is very easy from this simple trigonometric function. And similarly, Fy is again what? F sin theta, because sin theta is nothing but the ratio of opposite side to hypotenuse, Fy by f. So that is why f is equal to f. So earlier, when we resolved the given force into component forces in arbitrary directions, getting their magnitudes was very difficult. So but here, if you resolve a given force into an x component and a y component, getting their magnitudes will be very easy from these two trigonometric functions. But getting the directions is also important. So we normally we have to understand that vector quantities, the directions are also important. So to get the direction, we have to travel from the tail to the tip of the arrow to get the directions for x component and y component. Here it is so simple here, because the force is acting like this, the x component should be to the right and y component should be upwards. But in some cases, when we are dealing with simultaneously many forces, the resolution should also be perfect, the direction should also be properly marked. But to avoid any confusion, we can do this simple job: travel from the tail to the tip. So this point of application is called as the tail of the arrow, and this point we call as the tip. So start traveling from the tail to the tip in the direction of resolved components. So when you start here, if you think of first traveling along x direction, definitely you have to travel to the right, so that this Fx component is acting to the right. After coming here, to reach the tip, you have to invariably go upward. That means the y component will be upward here. So this method can be followed to get the directions of the resolved components. So normally we assign the directions also some sign convention. So if the x component is to the right, we call it as positive. If the x component is to the left, we call it as negative. And similarly, if the y component is upward, we call it as positive. And if the y component is downward, it is negative. So, but please note that the equations for Fx and Fy are given as what? Fx is equal to f cos theta and Fy is equal to what? F sin theta, provided the angle theta is measured with respect to the x direction only. But if the angle made by the force with the y direction is given, these equations won't hold good. But we always have to consider the angle made by a force with the made by the force with the x direction, so that the x component is f cos theta and fy is what, f sin theta. So with this knowledge, let us try to solve a numerical problem. The statement of the numerical problem is like this: the guy wire of an electric pole makes an angle of 30 degrees with the force, and it is subjected to a force of 10 kilonewtons. Determine the components of the force in the guy wire along horizontal and vertical direction. So we know that the electric pole has to be is vertically embedded in a ground. Sometimes to support this properly, a guy wire is attached at the top and pulled and anchored into the ground also. And that means the guy wire is here, that making an angle of 30 degrees with the pole. This is the situation, and it is subjected to a force of 10 kilonewtons. Means in the guy wire there is a downward force of 10 kilonewtons. So this is the situation. So this is the force which is acting in the guy wire. This force has to be resolved into its horizontal and vertical components. That is the meaning. So that, let us take the force. Now we know that the given force should be made to represent the hypotenuse of a right angle triangle. So with the force, how to get the right angle triangle? So this is the point of application. So through the point of application, draw an x-axis and y-axis, and now get a two set of right angle triangles. Consider any one and get your x component, y component. So this is nothing but our x component, and this is nothing but our y component, which we are supposed to calculate. So we know the hypotenuse, which is nothing but 10 kilonewtons, which is nothing but the given force. And here in this case, the angle is given as 30 degrees. But for us, we always consider the angle made by a force with the horizontal or x-axis. So that this we call it as theta. And definitely theta is nothing but 60 degrees, the complementary angle of this 30 degrees. And we already have the same functions to calculate fx and fy. Fx is nothing but f cos theta, and fy is, so that f is 10 and theta is 60 degrees. So mere simplification will get this as 5 kilonewtons. But please note that this is acting to the right, so this will be. And similarly, fy is nothing but what, f sin theta. F is 10 and theta is 60 degrees, so fy is 8.66 Newton, and fx is to the right and fy is downward.